recording as of right now. Just remember, if you put your hand up and say something out loud, that will get captured on the recording. So we're going to start with something called an introduction to functions. What are they all about? How do we know what things are functions and which ones aren't? This is section 1.1 in both textbooks. And so you can find this in both textbooks. I've, of course, attached the sections for today for both textbooks to today's lesson on EDSB. Okay, so you can find the textbook sections attached to today's lesson on EDSB. You can also find the solution set for this whole chapter, chapter 1, on EDSB in the content section. So I've put it there if you have any trouble accessing the solutions to the textbook problems. That's in EDSB, and that's for both textbooks. For the 11M textbook, it's there. For the 11U textbook, it's there. Okay? So knowing that, let's jump in. We're going to talk about these things called functions. So just some definitional stuff that we need to get through. Our first one is this thing called a relation. A relation is a really broad term. It just means there's a relationship between two variables. So pretty much anything that's can be written as a mathematical equation is going to be called a relation. It's any relationship between two variables. It could be the equation for a circle, or it could be the equation for a line, or it could be the equation for an exponential curve, or it could be the equation for a sine wave, or it could be the equation for any of that stuff we call a relation. It's all called a relation. Now functions are a specific kind of relation. They're a specific kind of relation, and we're going to get into some like really nitpicky language here, and that's on purpose, but I'll help you to understand what it means in plainer language as we go. So the kind of technical language, we say a function is a relation for which each element in the domain is assigned to only one element in the range. So that probably looks a little familiar, what we were just doing in that Desmos activity. But there's a lot of extra words in there, right? Like element and domain and range. We're going to spend some time learning more about domain and range. You have likely seen those before in grade 10, but you may not have. So our domain is our x values. Pardon my writing, it's a little weird looking there. And our range is our y values. Now we may not in any particular graph name it x and y. My background is in physics and I love physics, so we often will use variables like d for distance and v for velocity and a for acceleration. You don't really use x and y very much in physics. In chemistry, of course, there's a whole new set. So depending on the discipline you're looking at, the variables are going to change. But when we're talking about a function, we're saying for each x, that's the thing in like the left-hand column, we call that our input, right? So we could say x values or inputs if we're thinking about that activity we just did. So for each thing that's an x value or an input, there's only one thing that's a corresponding y value or output. Okay, that makes it a function. And again, you may be like, well, what does that even look like? We'll get there. We'll talk about visuals and graphs in a couple of minutes that'll help to make that a little more clear. So for each thing in the x column or the input column, that's only going to give you one thing in the y column, the output column. It can only give you one thing. It can't give you 2 or 3 or 4. If it did, it wouldn't be a function. So let's talk about our domain and range, right? Our domain is just all of our x coordinates. And again, we'll look at that later this week. And of course, it's looking from the horizontal axis, the x-axis. And we usually, when we do science, we call that the independent variable. So it's basically all the things you can have in your graphed thing, that all the possible x values you could have. So if you look at this graph to the right here, we could have an x value of 2. That's this point on the graph right there. That is an x value of 2. We could have an x value of 3. That's the point on the graph right there. We could have an x value of 0. We can have an x value of -2. So those are all parts of the domain. Our range, as you probably figured out, is just all of our possible y values, our y coordinates. It's on our vertical axis, and we in science we call that our dependent variable. It's usually the thing we're measuring after we do something. Okay, so we'll look at domain and range more specifically coming up. And set notation is just a way of writing things using curly brackets. So again, we're going to look at that when we look at domain and range. That's called our set notation. So I know you may want to write this down, but I am recording this and I'm going to post this PDF attached to this lesson when we're done. So I don't want to spend a lot of time just leaving class for you to write stuff, because you'll have access to these later. Okay, so if you're partially done, just leave a bit of space, and then it'll be easy to come back to this later, or you could print this off if you'd like to have just a printed copy of this. Okay, so I will post this as a PDF as well at the end of the lesson. So that's a lot of terminology, right? That's a lot of terminology. We kind of want to know what it means a little more, though. Okay, let's put a screen on here. So we're going to see which of the following things are going to fit into our definition of what a function is. So remember, to be a function, our x value can't have two y values. And there's a reason that's important when I think about physics. So here's an example: the height of a football after it's kicked. So here's our graph. H is our height, how high the football goes, and S is our time in seconds. S is our time in seconds. So when we're looking at this graph, at any given time, the ball has to be at only one height. Say, for example, 2 seconds after it's kicked. It can only be at one single height. It can't be at 2 different heights or 3 different heights or 4 different heights, because that would mean that, like, I don't know, that dimensions split apart, then you've got the ball in 4 different places at once. So because a lot of graphs have time on this bottom axis, in this case time in seconds, we can't have the ball in 2 different places. If the ball after, say this is 2 seconds right here, if the ball was here and here, that would mean the ball had split into 2 pieces or something. Or space-time warped and the ball is in 2 places at once, right? I'm sure there's some funny time travel shows about that, about people being in 2 places at once. So the ball can't be in 2 heights at one time. If we take any time, let's say we got 1 second, 2 seconds, 3 seconds, 4 seconds, something like that. At any given time, the ball can only be in one place. At 1 second, it's right here. At 2 seconds, it's a height of here. 3 seconds, the height is here. And at 4 seconds, it's practically on the ground. Okay? So it can only have one height at a time, so we say that is a function. For each time that's on your x-axis that you put in, you'll get a height. Here's another one. This is called a set diagram. So we want to know if this one is a function. So we're going to look at our input values. That's on our left here. That's usually where we write our x values, so right over here. And we're going to say for each of those, there should be only one output. So Alicia and Robert have the same number, but that's fine, because for Alicia, there's only one output, one number. For Robert, there's only one output, one number. They happen to be the same, but that's fine. For Jessica, there's only one output, so that's fine. But for John, he's got 2 numbers. So that means for our input of John, we get an output of 2 different values, so that's not a function. It's not a function. Now, usually we do this with numbers, right? We'd have numbers in the left bubble, and that would be our x values, our input values. And we'd have y numbers in our right column, and those would be our output values. But sometimes it's useful to think about it in terms of things that aren't numbers to help get a grip on it. So, example number 1 is a function, because for each input of time, there's only one possible height it can be. Example number 2 is not a function, because for each particular name, well, in some cases we have a name where it could have two different outputs, two different numbers, so that's not a function. Let's have a look at some equations. So here we have two kinds of equations. We got a linear equation. We can tell it's linear because the exponent is just a 1, which we don't normally write. And we have our quadratic equation. Did lots of these in lots of linear in grade 9, lots of quadratic in grade 10. We know it's quadratic because it's squared. So anything where the largest, the term with the highest exponent is squared, that's quadratic. So we say, well, which of these will be a function? Well, let's imagine that we're subbing in different numbers for x. Let's imagine for our linear one on the left. Let's imagine we put in a 1 for x. Well, 2 times 1 plus 1 is 3. There's only one possible output when we put in a 1. Let's say we put in a 5. 2 times 5 is 10 plus 1 is 11. That's the only possible answer. So this one on the left is a function. And the reason is, any value we put in for x, we will only get one single output for y. What if we look at our quadratic here? Let's say I put in a 1 for my x. 1 squared is 1. There's only one possible value. Let's say I put in a 3 for x. 3 squared is 9. 9 is the only possible value you can get out. So for whatever number we put in for x, there's only one possible number that we can get as our output, as our y value. So this is also a function. And we're going to say for each x value, only one possible y value. So for each input, there's only one possible output. So those are both functions. How about this one? Y is plus or minus the square root of x. Well, what does that mean? That means when we put in a value for x, we have to take two possibilities into account. The positive and the negative. This is telling us we need to account for both of them. So for example, if we said x equals 2, what would this look like? Well, y could be either positive, let's sub in that 2, root 2, or y could be negative root 2, and we sub in for 2. The positive plus or minus tells us we have to account for both of those. So because there's two possible outputs for each input, two possible y values for each x value, it's not a function. Let's say two possible outputs. Okay, so two possible outputs, y values, for each input, x value. We could also look at a table of values. This is another way to look at it. And this is a way we actually looked at it in the activity we did before this. So for each x, let's have a look at the y's. For -1, looks like we only have a single output. For -1, we end up with +1. For an input of 0, we end up with 2. For an input of 1, though, all of a sudden we end up with 3 or 4. There's two possible outputs for the input of 1. We plug in a 1 to our equation, we could get a 3 or a 4. So this is going to be not a function. Because we've got two possible different outputs for that input. Now there's a thing you can do when you're graphing these, and this is probably the easiest way, and this will help this make sort of graphical sense to people who like to have a visual example. So there's this thing called the vertical line test. Okay? The vertical line test. So if something is a function, when we graph it, it's going to pass this test called the vertical line test. So here's the vertical line test. First, we got to sketch the thing, the relation. We don't know if it's a function or not. So we're just going to call the general term, the relation first. We sketch it. And then we take a vertical line. If any vertical line drawn only passes through the graph once, I should say once, I wrote 1. Let's add a C in there. Once, then it's a function. So if any vertical line only passes through the graph once, it's a function. And if it passes through it more than once, then it's not a function. And often that means time travel, which is bad in terms of how we've drawn things. We don't usually draw time travel graphs. So I'll show you what I mean. Let's do some vertical line tests and see what they look like. I've got here 4 different graphs, and I've got a handy-dandy vertical line, this nice little red vertical line over here. I'm going to take this vertical line, and I'm going to move it over the graphs, and I'm going to try and touch 2 places on the graph at once. I'm going to see if I can do that. So I'm going to go to my first graph here. I'm going to start on the left. Looks like I'm only touching the graph, that blue part of the graph, in one spot. When I get right here in the middle, right to 0, there's a thing called an asymptote there. I'm not touching anything. And then I'm still only touching it once. In fact, there's nowhere I can move that red line on here where I'm touching the graph twice. Now the little arrow points on the end don't count, right? Because they just show that it's continuing. There's nowhere I can move this line where it's touching the graph in 2 places at once. So this first one is a function. It is a function because I can't touch the graph at 2 places at any one time. So we're going to give it a check mark and we'll say function. Oh boy, these are going a little haywire here. There we go. Function. Good. Okay, let's grab that vertical line again. Let's move over to our second one. I'm going to try and touch the graph at 2 points here. So there's nowhere I can touch it at 2 points. You might say like, oh, hey, right here you can. Well, here's a little thing with how we've drawn this graph. A solid circle means it counts. The graph exists there. An empty circle means it doesn't get quite to 4 on this part. So it gets to 3.9, 3.99, 3.9999, 3.9999, but never quite reaches 4. So I'm not touching 2 points on the graph right there because the lower one doesn't exist there. That's what that empty circle means. So I can't actually touch 2 points at once on here. So this one is also a function. can't hit it at 2 points at once. So we'll give it a check mark and we'll say function. Let's grab our vertical line and we'll head down to our third one. Now, can I touch this at any 2 points using my vertical line? Looks like I can right there. And I can touch it at 2 points right there. So in this case, my x value of 4, that's my input, has a y value of 2.5 and a y value of 4.5. And over here, my x value of, what's that going to be, 6.5, has a y value of 2.5 and 4.5. So I can touch 2 places at once using a vertical line. And you could just use a ruler for that. So that is, let's do it in red, a big X, not a function. My last one, I'm sure you can see this coming. We grab it, we move it along here, and it never touches it in 2 different places at once. So this passes the vertical line test. This last one is a function. So we'll give it a check mark. Oh, looks like my SmartBoard file might be wanting to crash here. No, we're okay. Excellent. So we'll give it a check mark and we'll say function. And this is like a huge section of math, functions. So there's actually a whole course in grade 12 called Grade 12 Math Functions. So it's all about this stuff. So this is like a huge part of the math you'll see going forward is functions. And they have very specific properties and they're used in very specific ways, and that's why they get their own category. And then we don't just call everything relations. Okay, so that gives you an idea of how we could look at functions. Just a couple of thoughts here. We could look at an expression using algebra and think about, okay, is there any number we can put in where we would get 2 different answers? That will tell us if it's a function or not. We could look at a table of values and see if a certain x value, a certain input, gives us 2 different y values. That would tell us if it's a function. We could also do the vertical line test, and that would tell us if it's a function. Sometimes things, instead of being written as a table of values, are written in kind of like ovals like this. Okay, and that's called a set diagram. So you will see those as well. Okay, so let's try some of those. I'm going to pause. I'm going to stop my recording here, and we're going to go and we're going to do a Kahoot as a class. So I'll pause my recording, and then we'll be moving on.